Hello, everyone. Welcome to BiogasWorld's Benelux Month webinar discussing the opportunities and challenges of the Benelux biogas market. As a reminder, this webinar is being recorded and will be shared with the participants following the webinar. In addition, if you have any questions for our presenters, we invite you to write them in the chat, and we will ask our presenters following their presentations or in the Q&A at the end of the webinar. BiogasWorld hosts new country-focused webinars each month to discuss the opportunities and challenges within various markets. Be sure also to join us on our biogas community website for the latest updates and to network with companies in the biogas and biomethane industry. I would like to thank our presenters for joining us today. Jafeth Bulsink, Head of Sales at Bright Renewables, Joachim Duprez, Head of Biogas Development at Peters Mixers, Jan Zengerink, Managing Director at Membrane Systems Europe, and Dries Neirink, Regional Business Director at Desotec. Our presenters today are suppliers headquartered in the Benelux region and providing a deep breadth of knowledge on this market. Peters Mixers are a supplier of mixers and agitators for digesters. Bright Renewables are a supplier of biogas upgrading and carbon capture systems. Membrane Systems Europe are a supplier of biogas domes and covers. And Desotec is a supplier of mobile filtration units. Before we begin our presentation, I would just like to take a moment to share some insights from the Benelux biogas and biomethane market. Looking to the left, we see a breakdown of where the biogas facilities are located across the Benelux region, with the largest market being the Netherlands with over 260 sites. Of these 260 facilities, approximately 1/3 are located at agricultural sites and another third at wastewater treatment facilities. Agricultural sites are the largest subdivision of facility type, accounting for a little over half of Belgium's over 150 sites, and most of Luxembourg's 23 sites. On the right, we see the proportion of biomethane facilities across the region. The Netherlands has led the development of biomethane facilities across the region, with over 80 of these biogas sites upgrading to biomethane. Belgium and Luxembourg have been slower to start, however, put forward targets in recent years to increase their output of biogases by targeting underutilized farm wastes and manures and converting existing CHP sites to biomethane. Looking at potentials across the region, we see that manures and green wastes hold the highest potential for continued development, followed by intermediate crops, agricultural residues, and industrial wastes. When examining regional targets, Belgium has been divided into its two main subregions, Flanders and Wallonia, which both have set separate regional potentials for biomethane development by 2030. Fluxies, the transmission system operator for Belgium, has estimated the 2030 potentials to be 8 terawatt-hours for Flanders and 7 terawatt-hours for Wallonia. The Wallonian government has set forward more aggressive target and is set aiming for 8 terawatt-hours by 2030. The Netherlands has set a 2030 biomethane target at around 10.5 terawatt-hours, short of the 16 terawatt estimated as feasible, but still a very ambitious target. Permitting and regulatory approvals remain a challenge for reaching these targets across the region, and therefore the conversion of existing CHP facilities for biomethane production is viewed as one of the most effective avenues for meeting these short-term goals. So thank you for your attention for this. We'll now move to our presentations. Our first presenter is Jafeth Bulsink, Head of Sales with Bright Renewables. He is a master in sustainable energy technologies with 7 years of experience in the renewable energy sector. He has made the switch to the biogas sector about 2.5 years ago. So thank you for your attention. Jafeth, I will pass the floor over to you.
Thank you, Ryan. I think you see my screen now. Yeah, okay, yes. Very good. Thank you for the opportunity to give a presentation here. Yeah, I've been asked to do a short presentation in a little under 10 minutes on the opportunities and challenges of the Benelux biogas market, which is going to be a challenge on itself, but let's see how fast we can get through it. First, I want to give a short introduction on Bright Renewables, and then we'll dive into specifically the opportunities and challenges for mainly Belgium and the Netherlands. So Bright Renewables, we are headquarters in the Netherlands, in the east of the Netherlands, in Enschede. We have a local presence throughout Europe and also in the US. So we have local people in France, Latvia, Italy, Germany, the UK, and then in the US. In total, we have 70 employees, which are the biggest part of them are based in the Netherlands. which are crossed over engineering, sales, project management, and service. And we've installed close to 200 installations globally until now. I just checked, of which approximately 60 to 70 in the Benelux. Partly biogas upgrading systems, but also a CO2 liquefaction system that comes up more and more. So Bright Renewables, we delivered it technology inside biogas plants from after the production of the biogas. So we upgrade biogas to biomethane or RNG if you're in the US. From the biogas upgrading that we do with three-stage membrane technology, we can liquefy the CO2 afterwards and make food-grade liquid CO2 from that. But also nowadays we deliver bio-LNG installations at the back end of our biogas upgrading technology, where you can produce liquid biomethane for transportation, for the transport sector, or if no gas grid is locally, and also of course bio-CNG fuels. So to dive into the opportunities and challenges immediately for the Benelux, I split it a bit in different opportunities and challenges, not directly linked to the countries, but it's named there. So if you look at the opportunity for subsidies, you have a very nice structure in the Netherlands on SDE++ subsidy for biogas and biomethane production, and also nowadays for liquid CO2 production at the back end of a biogas upgrading system. In Belgium, there are not a lot of subsidies available, or not at all. Although there you see a very big push on that the CHP run out of a feed-in tariff, and the biogas plant owners need to switch to do something else with the biogas they already produce. So there's still a big opportunity there next to the challenge that there's no subsidy. Projects are still happening, but you see, everybody can see it on the chart that Ryan just showed, is that there's a lot of potential in Belgium, but there's still a lot to gain on installing biogas plants and biogas upgrading technologies. The biogas market is also maturing more and more, so we see that it attracts a lot of attention from equity funds or large energy companies. I will dive into that a little bit more in the next slide, but especially that is seen that big companies buy biogas plant, revamp it, install biogas upgrading technology and/or CO2 technology, CO2 liquefaction technology at the back end of it to make biomethane and liquid CO2. There's a big surplus still in the Netherlands of manure. Also, what Ryan just showed in his slides. There's still a big opportunity of making biogas and then biomethane from it. Since Q4 of last year, we see a nice opportunity from the Netherlands or Belgium into Germany by selling your GOs and valorizing your green value of the biomethane into Germany. Nowadays, the quota price there is not so high anymore. But so we see not a lot of movement there, but before there was a lot of focus on bio-LNG before Q4 2023 to ship the bio-LNG from the Netherlands or any other country into Germany, because you could earn a lot of money with that. But since you can now inject it into the Netherlands or Belgium and valorize it in Germany after that, there's more and more focus on injecting it into the grid directly, which is of course in the end also the most energy efficient system. And there's a new, they call it in the Netherlands bijmengverplichting, but it's a mixing obligation on biomethane for energy companies, which is expected in 2026, which I'm going to dive into in the next slide. The challenges, as I said, in Belgium, there's a lack of subsidies, but there is still a big push because the energy companies that buy the biomethane and the NGOs are valorizing it, for instance, in Germany, or need it for their own portfolio. Big companies as Engie, we see quite a bit coming by in the projects in Belgium to buy all the biomethane that is produced. The permitting process for greenfield projects is a difficult thing in both countries. It's small companies or small countries with not a lot of room, so there are some delays in that, and to get the greenfield projects going. Digestate discharge is a problem we face in the Netherlands. To get rid of it, feed it into the gas grid. In the Netherlands, you see it's not so big of a problem to feed it in. In the summer, it can be an issue, but it's quite well regulated here. In Belgium, it can be a bigger problem because you have to comply to a high biomethane quality, which is fine possible with the biogas upgrading technology, but there are some other difficult stuff going around with the gas grid operators there. The biggest challenge, I think, for instance, especially in the Netherlands, is getting for a greenfield project, especially, and also revamping of CHP to biogas upgrading to get an electrical grid connection for biogas upgrading, but also for your bio CO2 technology. A little bit on the bijmengverplichting on biomethane, where we see a very big opportunity for CO2 liquefaction, biogas upgrading, and CO2 liquefaction in the end. But the goal in the Netherlands is to produce 2 billion cubic meter biomethane per year in 2030, which was 1/10 of it in 2022. The goal of the bijmengverplichting is to reduce 3.8 megaton of CO2 in 2030, which equals averagely on the carbon intensity score calculated on 1.1 billion cubic meter of biomethane. Meaning energy companies are obliged to buy biomethane from the market, which is then raised in a few steps until 1.1 BCM in 2030. That makes the market for biomethane much bigger, and lowering the CI score of it, of the produced biomethane, means also to a higher value of the biomethane for energy companies. So when you are liquefying your CO2 at the back end, you lower your carbon intensity score of the plant. Energy company gets a higher price for the biomethane. So there's real value in adding a CO2 liquefier at the back end. One problem or one challenge we see in that is that there has to be a guarantee on liquid CO2 offtake, because you need to get rid of the liquid CO2 afterwards. But this is a real push going on for adding CO2 liquefaction at the back end as low carbon intensity score as possible. And then valorizing it in your biomethane that you inject into the grid. Short, second to last slide, but one nice project we've did in the south of the Netherlands, in Tilburg. So there we started production in 2022 at the back end of a wastewater treatment plant, where we installed a 3-stage membrane system, biogas upgrading system with a capacity of 1,600 cubes per hour, and where we also liquefied the CO2 at the back end with 1,200 kilograms per hour. CO2 produced there is brought to the greenhouses locally that are using the CO2 for growing their plants and flowers. So I would like to invite everybody to ask questions, and let's bring as much green energy into the Netherlands as possible. Thank you.
Thanks for your presentation, Jafeth. One question we'll ask for our next presentation. So you mentioned the 3.8 megaton CO2 reduction target for 2030. So about how much biomethane, excuse me, it would be required to meet that target?
Yeah, so I mentioned it shortly, but it's approximately 1.1 BCM of biomethane in 2030, which means quite a big additional market which need to be valorized by the energy companies, with only 0.2 BCM in 2022 produced. So there's a big reduction aimed to get it, and it's a big opportunity also to valorize more and more into the biogas market.
Great, thank you. We'll get to the other questions with time at the end. So next we have Joachim Duprez. Joachim has been building biogas plants for over 20 years and has 15 years of experience in the biogas sector. He's been operating his own plant in Germany for 10 years. For Peter's Mixer, he helps customers worldwide to find the best mixing solution for their input. So I'll pass the floor over to you.
Thank you, Ryan. I will show you my presentation. So I hope you can see it.
Yes.
I will take two parts of this presentation. The first part, I will show a few pictures. What is Peter's building, where we are coming from, what we do. And in the second time, I will show some examples of the some plants in the Netherlands, in Belgium, or Luxembourg, and I give you a focus of the future in Luxembourg with some examples where you can. The company Peters is a family company in the third generation. It's starting with Bernard Peters. At the moment, it's Jean-Marc Peters and Martina Peters, and the second generation, Max Peters, is also now part of the company since 2 years, and so it goes on also in the future. In the history, I only give 2 steps. In the middle of 80s, we start with agriculture mixers to help farmers where the farms grows up, and manure was a problem to mix it to come to the fields. And the end of the 90s, the first farmers think about also in the area of Luxembourg to use the menu for biogas, and they want to take the same mixes which they got till yet. We install them in an engine, and we make in these years a lot of experience what is possible and what is useful to do in biogas plants. And so the end of 90s, the beginning of the 20s, we make a lot of experience. We test some products, and till today we have some parts of products which is designed in this time and still working till today because the experience was really good. Our factory produced from the design. We got a separate design office. The most of the parts by our own, and complete to the installation on site and the service later. We make the complete line from A to Z. The big advantage that there are some mixer manufacturer on the market, but we are a little bit specialized because we are more than 20 years in the biogas market. We have some mixing system which can work with higher dry matter. So later I will show you an example in Luxembourg, which is one of the heaviest biogas plants in the kind of driving. And also to change levels, our mixing system can work with changing level. These are also specialized for our company. And in the next steps, this is a step which Germany goes in the last year: higher efficiency, less own power to use in the mixer. This was one of the important things for our customers. There we make a lot of reference in the last years because it was more and more, and it becomes to a standard. And the next step is, or at the moment, a lot of biogas plants want to change the input material to use more grass, more solid, and drive with higher dry matter. So for that, we come on a lot of time to existing sided and change the system there. Peter's mixers are with agriculture mixers worldwide on every place on the world. With biogas, we are nearly all countries where with biogas installed. So this card shows the main countries where we install biogas plants. We are located in Eupen. This is the east of Belgium, near to the border of Germany and the border of the Netherlands. You see the three big countries around us: Germany, it's France, and it's Great Britain. These are our main customer countries. But of course, we start in the Benelux, and in our history, Luxembourg was one of the important countries to start. Also Germany, also Belgium. But in the history, Luxembourg was so important that we still have till today a sales office in Luxembourg, and this is also where I was located in my job. And so some facts about Luxembourg. It is a small country, but like Ryan shows in the first foils, 26 plants, biogas plants are all over the country. The most are with electrical powers, only 3 with methane to the grid, and but it is 5% of the complete energy mix of Luxembourg, and it seems to be then a lot from only 26 biogas plants. 120 farmers deliver cattle manure to the biogas plants. So in the history, Luxembourg take a lot of farmers to one plant. This was in the history from the government pushed. And so there are some biogas plants where 30 farmers delivered to one place. Yeah, and so at the moment, 200 gigawatt per hour is the what they produce, and per hour per year, and 3,000 households can be benefit from this carbon heating. In the future, there was an analysis, a study from which the government ordered. They have to look what is possible to use in the biogas plants in the future, because then they can choose how much permissions they will give, and how much can they calculate to use in the whole grid of electricity and of gas. And so they make a study, and they told them 330 gigawatt hours per year is possible. So then we know 60%, about 60-70% is installed till yet, and it's possible to install more than 30%. But I have to say, we will see. It's only a study. The last 10 years in Luxembourg, nothing happened. So only the biogas plants which are installed are in operation, but no new biogas plants will install. So this is also a problem in the government, and they think about what can we do, and they make new rules, and they give the smaller plants up to 100 kilowatt 26 cents per kilowatt. So in the future, since this year, since the end of the year, you can build a biogas plant and you get a higher volume of a higher amount. Till 2 years ago, it was some cent less, so nobody can build, nobody are interesting to build. The same they did with the gas. They push it a little bit in the prices, but biomethane is a little bit problem in Luxembourg, because there was not a so big grid to go to connect to the grid, and so the most biogas plant will also in the future work with electricity and go with electric power to the grid. I will give you three examples of biogas plants. The first one is in the Netherlands. It was the biggest puddle mixer we built in diagonal tanks. It was a post digester. It was 10-meter high. And the big advantage is they changed the level. So in the wintertime, they are full. In the summertime, they are nearly less empty. But they don't have to think about the mixing layer or something else. With the bottle mixer, you are every time on the correct layer and you mix every time you tank. The next example is from Luxembourg. It was one of my famous biogas plants because I was the project leader in the year 2014 and 2015 of this project. And it's a project with a high efficiency because there is also, it's located in Junglinster. There is also no gas grid, but the owners think, what can we do to make it efficient? They took also 20 farmers to get the input. They go to the industrial zones, which is about 1 or 1.5 kilometer next to this biogas plant, and sells all the heat. And so for that, it's a really efficient and useful biogas plant. From the input situation, they drive high dry matter, so more than 40% dry matter part in the fermenter. And the limit is not the agriculture, the limit is there with a pump. If you go much or at any point higher, you cannot pump it out from the fermenter, but we still mix it. So a really nice project and a high efficient, and this is something which is also work in the future with the new rules of the government, and if they use heat, also in Luxembourg, I think in the future some biogas plant can become like this. And the last one I want to show you from Belgium, an example. It was a customer which has an input of waste. It was a kind of waste from the industry, from the food industry. It was a kind of waste from the Haber, which come to him and in different charges. And he has to install an hydrolyze and in front of it. And we install in the hydrolyze the mixers in stainless steel and the fermenter digester. Also the mixing system is paddle mixer and stuff, watt mixers in combination, and also post fermenter and storage tank. So it's also a really beautiful plant, and yeah, with another idea, because they can use waste from the food industry, and so it's also a biogas plant where I was sure that also works in the future. So I hope I take the time and give you some information. If there are questions, of course, please let me know. I will give you an answer or try to give you an answer.
Thanks for your presentation. You gave a very extensive overview of the industry in Luxembourg. Thank you. So do you see Netherlands, Belgium, and Luxembourg are similar or different when it comes to the building of new facilities?
I think there are really different. It takes every time what the rules from the governments are, and the three countries got their own rules. And like I told for the example of Luxembourg, if there are the last 10 years not the best situation for the farmers, nobody will invest. And so now they did the next step. Maybe in Luxembourg come also in Belgium come also a step. In Netherlands, I don't know the situation exactly. They got a easier situation for the biogas plants because they can easier connect to the grid. But we are not sure how the future, how fast will be the future happy to use more biomethane. And so I think this is a main key for stay or fall with the biogas plants.
Great, thank you, and thanks for your presentation. Next, we have Jan Zengerink. Since the founding of Membrane Systems Europe in 2011, Jan has led marketing and international sales. Jan's management experience includes leadership roles in South and North America, combined with 10 years experience in the international biogas market. So Jan, I'll pass the floor over to you.
My name is Jan Zengerink. I'm active in the biogas business since the end of 2006. Based in the Netherlands, 56 years old, and I'm partly owner of the company Membrane Systems Europe. I will tell you a little bit about our company, corporate story, and then later on go over to the opportunities in the Benelux. I thought that with this webinar I might meet a lot of new people, but I see that almost all of them I know. So it's still very interesting. Okay, our corporate story. Let's say we are specialized. We are a company with two companies in the Netherlands, Membrane Systems Europe and Dutch Cover Solutions. We do approximately 20 million euro in sales, and most of our products, they are double membrane covers, 100% high frequently welded in factories all over the world. We have factories in Germany, we have factories in India, we have factories in Spain, and we work with factories in the United States, where we are market leader in the so-called double membrane covers. We also do with Dutch Cover Solutions, we do single membrane covers, and we do so-called concrete protection inside of concrete silos. We are part of the company Serge Ferrari. That's the company where the membrane, let's say the foil, the technical textile is produced. This is a French company. Listed at the stock market in Paris, approximately sales 350-360 million euro. We have a sister company in Germany, DBDS, Deutsche Biogas Dachsystemen, and we right now have a subsidiary in Spain. We bought a company a few years ago, Up Biogas, and we are about, I have to sign the papers for Membrane Systems America to have a subsidiary in South America. We installed in total, I think, in about 60 countries all around the world. We have a lot of unique selling points. We consider ourselves having one of the best roofs that is available. That's also one of the reasons that, for example, Bright works with us. With special design, done a lot of installation. I won't go really into this. Where I really would like to go in is that we are specialized in adding a new aspect to a roof, and that is in insulation and the solar concept. Here you can see countries in the world where we have done installations, and you see here is the Netherlands, here you have Belgium, and here you have Luxembourg. And last week I was still in Luxembourg to sell some single membrane and double membrane roofs. We comply with all the necessary codes to have the highest standard. And what's interesting is that we have, let's say, we apply with the so-called Euro Code 1. And when a building in Europe is built according to Euro Code 1, then it applies with the fact that a human being must be able to live in it. So in case you want, you can buy a silo, you can put a double membrane or single membrane on it, and you can live with it. But that's the highest standard possible for construction. What we have seen in the past, and it's very interesting, especially we started with this in the Netherlands, and we started with this by a sister company of Bright with Host that were insulated roofs. So when you have seen in the biomethane world, that biomethane, I think it's still quite a small world. When I'm well informed, and we have worldwide about 30,000 biogas installations, and a few years ago there were only, or 2 years ago, there were only 3,000 of those, where about 10% that was biomethane. And the expectation is, in my opinion, that this market will really go into the biomethane applications. So a lot of traditional biogas installations where electricity is produced will be converted into biomethane installations. And in those biomethane installations, it's important, let's say, that you have a better energy balance. Normally, when you produce electricity, there's abundant heat to heat up the digester, to heat up the liquid, etc. When you do biomethane, it's not a case. So sometimes you have to even buy electricity to heat up the digester. And in that case, you really have to look at the energy balance. It's interesting that when you have a silo, and a silo is, for example, made of concrete, then at the walls, there you put a lot of insulation, etc. So to make sure that there's not a lot of heat lost through the walls, but on the top you have PVC, a double PVC, and there's quite some energy loss on the PVC, on double membrane roof. And we have developed 3 concepts to reduce this energy loss. And one of the concepts, it's an elastomer. It's a foam that is 16 millimeter or even a little bit thicker if you want. That will be added. That will be like glued to the internal membrane, and that makes sure that you have a reduction of heat loss through the roof of about 50%. It's quite interesting, and we apply this a lot in the Netherlands. And why is this very interesting in the Netherlands? Because in the Netherlands, you don't have a lot of snow. So in the Netherlands and also in Belgium, you can apply these concepts without any risk. When you go to other countries where there might be a lot of snow, you have to be a little bit more careful, because sometimes you also need the heat from the digester to melt the snow that might lay on the roof. So we apply this foam concept. We apply this in many countries, but most of them it's done in the northern part of France, in the Netherlands, and right now we also go to other countries. In 2006, one of our partners, where we do the welding, they started in the they applied aluminium coating on the PVC material to have a little bit of mirror effect, and this aluminium coating made sure that infrared, let's say, would be reflected. So with this application, you have a reduction of heat loss of about 20% on an internal membrane. We have a patent on it for an internal membrane, so this is what we also apply a lot in the market for biomethane. Then we have a third, and since recently we have a third layer membrane. In France we call it trisolateur, and we call it in England trisolator, and that means that is an additional third membrane that can be put between the internal and the external membrane, especially on installations that right now will be converted from electricity into biomethane. And we expect a lot from this. So we apply the concept of insulated roofs. When you look at U values, and then there are some discussions, but normally at the U value, you have a heat loss, we think, about 2.75 to 3.0 watts per square meter per difference per degree Kelvin. You have to say per Kelvin. And that can be reduced up to 20 or 50%. And so these are U values that are really interesting, and they give a pay that reduces the payback time of the material to a few years, and so quite interesting. What we also have done recently, and we have installed flexible solar panels on a single membrane roof. And we are continuing developing this concept, and right now we are getting up to payback times of about 3 to 4 to 5 years. This gets very interesting. In the market of the single membranes, there's not a lot of difference between several producers. So we wanted to make the extension and the difference by adding solar panels to it. This is a everybody all around the world likes it, but we have to improve this concept due to the fact it's still not ATEX satisfied. But when it's ATEX certified, then we can roll it out all around the world. This one is a very interesting product, and here you see a double membrane that is used for the storage of CO2. And then we go to the Dutch market, the Dutch biogas market, and the Belgian biogas market, and the Luxembourg biogas market are relatively small markets, but just like all the other ones, interesting because we can apply a lot of normal rules or insulated rules. But what we see in the Netherlands we have a lot of greenhouses. And this greenhouse technology is well known in the world. And we see a lot of people coming to greenhouses in the Netherlands to learn and for technologies they apply. This is an installation we have done in the Netherlands. And this is a roof, and I think it's 19 meters long. And it's 16 meters. The width is 16 meters, and the height of the membrane is 8 meters. And there's only storage of CO2. And CO2 right now has a value. That's interesting. In the past, it didn't have a value. So you see a lot of requests also from the United States. Due to the fact that in the Netherlands, we are very good apparently at greenhousing and at CO2 storage. So this is a very interesting market for us. Another thing what is very interesting to say also in the Netherlands, let's say the Netherlands, we are quite entrepreneurial from cultural point of view. We are more entrepreneurial, more risk-taking, I have to say, than other countries around us, like Germany, for example, or like France. So we also have supplied domes for products like these, but then round for the storage of hydrogen. And we expect the market to, let's say, also to see opportunities for hydrogen coverage. So we have done several in the Netherlands, but we will also export this concept. So we really see the Netherlands and also Belgium and Luxembourg as, let's say, as markets where we can try new products and then can export these products. When you look at other huge good possibilities for us, then we talk about also Luxembourg. Nowadays, in Luxembourg, you have the obligation to cover manure silos that you do with single membranes. This is since the mid-80s already, last century, already the case in the Netherlands. Also, right now, it started in Germany, and it's also the case in Belgium, but it's also the case in Luxembourg. So this is also an interesting market for us. We next to it, also almost coming to the end of our presentation, we have a web shop, and there that's approximately what we do in the Netherlands and in Belgium and in Luxembourg.
Great, thanks, Jan. So one quick question before we move on. So how do your membranes and biogas domes contribute to the sustainability and environmental friendliness of these energy solutions? So what specific advantages might they offer compared to traditional energy storage?
I can tell you a very nice story. People ask me whether they could store hydrogen in a biogas dome, and I said it's not possible. And then the client said, yes, it's possible. I said, it's not possible. And then he said, it's possible. I said, I know something about membranes, so I don't think it's possible, because the products, according to our spec sheets, they have a certain permeability, and already some CH4 is escaping from it. Although we have according to the papers, the lowest permeability in the market is still escaping. So I thought that H2 molecules might escape quickly. Then we did a test, and we found out that most of the H2 molecules still stayed in. So the permeability was quite low. Then I asked our production in Germany, but how is it possible that you have a certain permeability, and in reality, the H2 stays in? And then the German said to me, yeah, but the reality is that our permeability is about 10 to 15 times lower than what we mentioned in the papers. because we want to be at the shore sites. So there you see the difference in risk taking, let's say, or being more careful about where you apply the products between Germany and the Netherlands. So yes, we have a base material. We have a base material that's has an extremely light permeability. That's one of the examples.
Great, thank you. Thanks for your presentation.
Thank you very much.
Next, I'm happy to introduce Dries Neirink from Desotec. Dries is the regional business director for the Benelux. Dries will talk to you about the takeback of sulfur-loaded activated carbon after H2S removal from biomethane. This mostly hazardous waste is today an issue for the industry, and Desotec has a solution for that. So, Dries, the floor is yours.
Thank you, Ryan. I will share my screen. And I hope you are still all awake and full of energy to listen to the last speaker of this afternoon. I changed a little bit my title because we're talking about challenges indeed, and it's definitely a challenge to get rid of waste or to get rid of sulfur-loaded activated carbon. But luckily, Desotec has a solution indeed for that. Let me first introduce Desotec to those who don't know Desotec yet. We are a supplier of mobile activated carbon filters. We have a fleet of approximately more than 4,000 filters. We are with 400 people generating 150 million euro turnover and have a availability of 24/7, meaning we deal with emissions a lot. So we have a fast possibility to act fast and react fast on questions. We are active on both regions, North America, where we have our headquarter in Darlington, Pennsylvania, and also some reactivation furnaces, which we also have in Parker, Arizona, and Red Bluff, California. Here in Europe, we have our headquarter in Belgium, where we have 4 reactivation furnaces, and then we have 4 hubs across Europe to fill and empty these mobile filters and transport waste up and down. In this presentation, I want to first of all talk to you a little bit about what is activated carbon in the end. Most of you most probably have already experienced with it, but also the difference about physisorption and chemisorption, because you need different kinds of carbons for that, and you have different kinds of waste scenarios afterwards. So that will bring me then to the last part of this short presentation. It's about closing the loop on high sulfur loaded activated carbon. But first of all, what is activated carbon? Activated carbon is in the end a non-hazardous product. It's carbon-rich materials, and it has typically a very porous structure. So thanks to its large internal surface, it can absorb impurities. And that's thanks to an activation process. During this absorption process, like I earlier said, there are 2 types of absorption. But let me first deep dive into biogas. What we do over there is typically with mobile filters, we will remove H2S from biomethane or biogas to protect engines, but also to protect the membranes behind. Also, VOCs and solvents might need to be removed, terpenes and siloxanes or other unwanted pollutants. And then we put this activated carbon in a mobile filter vessel, which is easy to install. Now, VOC removal is typically done via physisorption with activated carbon. And at the right-hand side here, you see how the carbon is looking inside. So larger molecules will be attracted thanks to the London dispersion versus into these larger pores. And the smaller molecules will be adhesed in the end in the small pores. And so it's a exothermic reaction, which is reversible. This carbon, which is saturated, we can bring it into our reactivation furnaces, and under the process of pyrolysis, it will become volatile again. The molecules will remain unchanged. And typically, with the physisorption process on activated carbon, we talk about a carbon backbone of the molecules that we will attract. For H2S, it's a bit different. H2S removal is typically done with chemisorption, and chemisorption is only happening when there is a chemical reaction between the adsorbate and the surface. With other words, you might or will need a chemical compound to create a reaction on the activated carbon. And that reaction on the carbon is an irreversible reaction for these anorganics, which is not possible to clean away this carbon afterwards today in a classic reactivation process. However, Desotec is currently building a new facility to be able to take back this carbon. What is typically for our business is that we deal with mobile filters and work from a 5-step service business model. So typically we will treat emissions or treat impurities in biomethane. We'll deliver a mobile filter, which you see here at the left-hand side of this slide, which is easy to install, plug and play. Within 20 minutes, a filter can be exchanged. So on the continuity of your process, that makes a big difference. In the 4th step, you see that we will be able to take back in a sustainable way saturized carbon, and we will remove in the end the impurities from that carbon in a controlled process and ship back these filter vessels to customers. Now, how can we help you to close the loop with sulfur-loaded carbon? Sulfur-loaded carbon today is a waste flow which need to be burned, which is creating emissions. Thanks to our new process, we will be able to reuse that high sulfur-loaded carbon, and we will produce from that carbon a fresh new carbon. So during that process, zero discharge will happen, and byproducts will be converted into valuable resources. You have the carbon, first of all, itself, which we will use to produce new impregnated carbon, but you also have steam as a byproduct, which we will use to generate electricity. And the sulfur will also be saved because we will produce gypsum during that process. So we can say that it's a closed loop, circular, cost-effective innovation for the biogas market. Here you see some typically statements. First of all, we will be able to reduce CO2 footprint. We will no longer be, it will no longer be needed to burn the saturized carbon, but we will be able to gain it back. And also we will be less dependent on sources from the Far East, which is creating CO2 during these transports over the ocean. Also, we will be less dependent on non-European sources. We will be able to produce Belgian-based carbon. And also we will meet current and future environmental standards. Of course, when we produce a carbon out of waste, you can have some questions. You can have some questions about sulfur loading. What about my process? What about the stability? We did some tests already before our installation was already up and running. And we saw that the equivalent of sulfur loading is the same like with the Asian activated carbon. We also see that you don't need to change your process conditions. Typically during H2S removal, you need to add oxygen or you need to increase your relative humidity. It's the same rate like the carbons which are produced in the Far East. And it also is showing an equal stability. This is all monitored by our own lab and our own R&D division, of course, who is doing typically analysis on density, iodine number, and impregnation level. It's a thermal process. Some of you might ask, why are you not simply washing the carbon? But we do it in a thermal process because we did during a decade tests on this. This is a new installation that wasn't developed on one day next to another. So we have been busy with this for more than 10 years now. And we saw that it's an effective and efficient way to separate the sulfur, the organics from the activated carbon. It's in the end complete removal and destruction during this process. And there will no cross-contamination happen of the pollutants between different clients because we will produce batch-wise and in the end do a quality check as well. And there is elimination of the liquid discharge. On the other hand, addressing the SOx emissions during this process, we will be converting them into gypsum. So that will be a sustainable byproduct for the construction industry and make that all byproducts in the end are valuable in that way. So this is a patented system or a patented production unit, which will start up during next quarter. Here you can see a small picture of this installation, which is under construction now, but up and running soon, where we state indeed that we are working further on a cleaner and greener world for all of us. Typically, Desotec was already pushing hard on sustainability with the take back of VOC carbon and in our treating them in our standard reactivation furnaces. So happy to announce that we will be able to take high sulfur spent carbon as well. In case you want to see more cases, please visit our website, or if you want to contact myself, here are my contact details. Any questions?
Great, thanks for your presentation, Dries. So you mentioned it'll be online in a few months. What countries will it serve?
We will be able to take back all over Europe this satirized carbon, because we have hubs in different countries, and at these hubs we are able to store waste and bring it then combined to Belgium to do that in an efficient way. You might think about crossing the borders with dangerous waste. In such case, we do have notifications, we do have a division who is taking care of all these waste administrations across Europe.
Great, thank you. So that brings us to the end of the hour for our time today. If we're unable to get to any questions, we'll share them with our presenters and invite them to create a response for you. We invite everyone to join us on our Biogas community platform to stay up to date with content from our Benelux, Focus Month, and participate in July's Focus Month on emerging markets, Ireland, Turkey, Greece, and Australia. I would like to thank everyone for taking the time to join us today, and thank our excellent presenters, Jafeth Bulsink from Bright Renewables, Joachim Duprez from Peter's Mixers, Zengerink from Membrane Systems Europe, and Dries Neirink from Desotec. Thanks everybody, and have a great weekend.